The relation between the roots of the quadratic equation and its coefficients. Let the quadratic equation ax square plus bx plus c is equal to 0 and the roots are alpha is equal to minus b plus into root b square minus 4ac upon 2a and beta is equal to minus b minus root b square minus 4ac upon 2a. If we add these two roots, that means alpha plus beta, if we add these two alpha and beta, we get minus b plus root b square minus 4ac upon 2a plus minus b minus into root b square minus 4ac upon 2a. 2a, the denominator is same, that means we have to add the numerator minus b plus into root b square minus 4ac minus b minus into root b square minus 4ac divided by 2a. Minus b, that's get minus 2b and plus b into root b square minus 4ac minus into root b square minus 4ac, which get cancelled, hence minus 2b upon 2a, 2 get cancelled, hence which get minus b upon a. Therefore our first relation get alpha plus beta is equal to minus b upon a. That is our first relation. Now we have to multiply these two. We get now alpha into beta, that means into first bracket minus b plus root b square minus 4ac upon 2a into minus b minus into root b square upon b square minus 4ac upon 2a. The numerator and the denominator get multiplied. Minus b plus root b square minus 4ac into first bracket and into second bracket minus b minus root b square minus 4ac upon 2a into 2a, that is 4a square. Here b square plus into root b square minus 4ac and b minus b plus into root b square minus 4ac minus b minus into root b square minus 4ac. That's get in term of a plus b and a minus b. That means we have to multiply this, we get a square minus b square. Hence this we get here the square of the first term, that is minus b bracket square minus the square of the second term, that is root b square minus 4ac bracket square upon 4a square. Hence which get the square of minus b square is b square minus b is b square minus, we remove that square root, we get b square minus 4ac because the square of the square root is that value only upon 4a square. Hence we get b square minus b square minus get plus 4ac upon 4a square. B square get cancelled, hence 4ac upon 4a square, 4 get cancelled and a square, that one is cancelled, and hence we get c upon a. Therefore another relation we get alpha into beta is equal to c upon a. That is another relation. if the ax square plus bx plus c, this quadratic equation is given and alpha and beta are the roots of the quadratic equation, then the sum of the roots is equal to minus b upon a, and the product of the roots, that means alpha into beta, is equal to c upon a. That is the relation between the roots and the coefficient of the quadratic equation. Now we see some examples on it. Here in the first example, if alpha and beta are the roots of the equation 2x square plus 6x minus 5 is equal to 0, then find the value of alpha plus beta and alpha into beta. Comparing the equation 2x square plus 6x minus 5 is equal to 0, we compare this equation, the equation with ax square plus bx plus c is equal to 0, we get a is equal to 2, b is equal to 6 and c is equal to minus 5. Now our formula of relation between the roots and the coefficient, we get alpha plus beta is equal to, the first part, alpha plus beta is equal to minus b upon a. That means alpha plus beta is equal to minus 6 upon a is 2, that is minus 3. Hence the first part, alpha plus beta is equal to minus 3. Now second part, alpha into beta is equal to c upon a by our formula. Hence substitute the value here is equal to minus 5 upon 2. Hence alpha into beta is equal to minus 5 upon 2. Hence our final answer is alpha plus beta is equal to minus 3 and alpha into beta is equal to minus 5 upon 2. Now second example, find k if one root of the equation 5x square plus 6x plus k is equal to 0 is 5 times the other. Let the equation is given 5x square plus 6x plus k is equal to 0. Let the equation, given equation is 5x square plus 6x plus k is equal to 0. That means a is equal to 5, b is equal to 6 and c is equal to k. And let alpha and beta are the roots of this equation. Okay. The given condition is the one root, that means first root alpha is 5 times of the other, that means alpha is equal to 5 beta is given. Hence alpha is equal to 5 beta, which is by given condition. By given condition, we have our formula alpha plus beta. By first formula, alpha plus beta is equal to minus b upon a. Substitute the value of alpha at here, that means 5 beta, we will put 5 beta at here. Hence 5 beta plus beta is equal to minus b, that means minus 6 upon a, which is 5. And hence 6 beta is equal to minus 6 upon 5. take to 6 the another side, we get beta is equal to minus 6 upon 5 into 6. 6 get cancelled, and hence beta is equal to minus 1 upon 5. We get the value of beta. Then now the second condition, now the product alpha into beta is equal to C upon A. Now alpha is phi beta, that means phi beta into beta is equal to C, which is K upon A is phi. Hence phi beta square is equal to K upon phi. Now put the value of beta is equal to minus 1 upon phi. Hence phi into bracket minus 1 upon phi bracket square is equal to K upon phi. Take the phi the another side, hence we get phi into the square of this is 1 upon the square of phi is 25 into here this phi is multiplied at here, phi is equal to K. That phi get cancelled, and hence K is equal to 1. That is our final answer. Now the third example. If alpha and beta are the roots of the quadratic equation x square minus 4x plus 1 is equal to 0, find the value of alpha square plus beta square, and second alpha upon beta plus beta upon alpha. Here the equation is given x square minus 4x plus 1 is equal to 0. We compare this equation with ax square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to minus 4, and c is equal to 1. Now alpha plus beta is equal to minus b upon a. That means alpha plus beta is equal to minus into bracket minus 4 upon 1, which is 4. Hence alpha plus beta is equal to 4. That is first value we get. Now alpha into beta, alpha beta is equal to C upon A. That means 1 upon 1. Therefore alpha into beta is equal to 1. We get the another value. Now we have to first find alpha square plus beta square. We know the expansion formula. Alpha plus beta bracket square is equal to alpha square plus 2 alpha beta plus beta square. Take 2 alpha beta to the left hand side. We get alpha square plus beta square. Hence alpha square plus beta square is equal to into bracket alpha plus beta bracket square minus 2 alpha beta. Now substitute these values at here. Alpha plus beta is 4. 4 bracket square minus 2 into alpha into beta is equal to 1. And hence we get the square of 4 is 16 minus 2, which is 40. Hence alpha square plus beta square is equal to 40. This is equation number 1. Now the second value. Alpha upon beta plus beta upon alpha Here the denominator is not same, that means we have to make denominator same by by LCM getting alpha beta, or by cross multiplication. We multiply alpha to the first alpha, which get alpha square, beta into beta, that is beta square, upon the product of the denominator, that is alpha into beta. Now alpha square plus beta square is equal to 14. In the equation from 1, write the value 14 upon alpha into beta is 1, from 1, and hence we get alpha upon beta is plus beta upon alpha is equal to 40. That is another value. Now the fourth example will be on this. Now fourth example, if one root of the quadratic equation x square minus 8x plus k is equal to 0 is 4 plus root 3, find k. Here the equation is given x square minus 8x plus k is equal to 0. We have to compare this equation with ax square plus bx plus c. We get a is equal to 1, b is equal to minus 8, and c is equal to k. Now one root is given. Let the roots are alpha is equal to 4 plus root 3. One root is given 4 plus root 3. Here the root is irrational number. If the roots are irrational number, then alpha and beta are the consecutive pairs. I repeat, if the roots are irrational number, here 4 plus root 3, which is the irrational number, and hence if the alpha is 4 plus root 3, then the beta is 4 minus root 3. This is the consecutive pairs. Okay, if alpha is 4 plus root 3, the another root is 4 minus root 3. We have to change this middle sign. Now alpha into beta is equal to 4 plus root 3 and 4 minus root 3. The product of this is equal to the square of 4, because of a plus b and a minus b. That means the square difference between the both square of both that terms. The square of 4 minus root 3 bracket square, which get 16 minus 3, that means 30. Alpha into beta is equal to 30, but alpha into beta, the product is equal to c upon a, and hence c is k upon 1 is equal to 13. Therefore k is equal to 30. That is, k value of k is equal to 30. Now the next part is to form the quadratic equation if the roots alpha and beta are given. Now to form the quadratic equation if the roots are given, let alpha and beta are the roots given of the quadratic equation. Let alpha and beta are the roots of the equation. Now we do the reverse procedure of solving the quadratic equations. Alpha and beta are the roots. That means x is equal to alpha or x is equal to beta. We get the reverse form, reverse of solving, the reverse of process of the solving of quadratic equation. This is our solution. Alpha and beta are the roots of the quadratic equation. That means alpha, x is equal to alpha or x is equal to beta. Take alpha to the another side. We get x minus alpha is equal to 0 or x minus beta is equal to 0. Now we have to get the product of these two. We get x minus alpha into x minus beta is equal to 0. Now the process is the reverse of our solution of the quadratic equations. Now we have to get the simplify these two bracket. We get x into x, that means x square into x into minus beta is equal to minus beta x. Now alpha minus alpha into x, that is minus alpha x, and minus alpha into minus beta, that get minus alpha, minus minus get plus, plus alpha beta is equal to 0. Now add these two terms, hence we get x square minus into bracket alpha plus beta into x plus alpha beta is equal to 0. This is our required equation. If alpha and beta, the roots are given, then we can find the equation. That means x square is equal to x square minus into bracket alpha plus beta x plus alpha into beta is equal to 0. That is our required equation if alpha and beta, the roots are given. That means the square of the variable minus the sum of the roots into x plus this is the product of the root. Is equal to 0. This is our formula. If the roots are given, then we can find the quadratic equation. The formula is x square minus sum of the roots into x plus product of the roots is equal to 0. Now we see the examples on it. Now the example is form the quadratic equation if the roots are 3 and minus 10. That means two roots are given. One is 3 and another is minus 10. And alpha is equal to 3 and let alpha is equal to 3 and beta is equal to minus 10. Now the form of the equation if the alpha and beta roots are given is x square minus alpha plus beta x into alpha into beta is equal to 0. That means we have to add these two root and product of these two root. Hence alpha plus beta is equal to 3 plus minus 10. That means 3 minus 10 is equal to minus 7, and alpha into beta is equal to 3 into minus 10, which is equal to minus 30. Substitute this in the equation, we get, let the equation become x square minus alpha plus beta is equal to minus 7x plus alpha into beta is equal to minus 30 is equal to 0. And hence the required equation is x square minus minus get plus 7x minus 30 is equal to 0 is the required equations of the roots are 3 and minus 10. Solve the examples on this in the given book.